problems. The next big problem, even worse, is when you're using multiple developers, like 2 or even more, that work on the same code on one server. Developer A uploads his stuff, the second one uploads his stuff, overwrites the other one's stuff, the thing's broken, or even worse, the old developer's A work is lost on the server. This, just for short, sucks big time. So I'll try to show you some steps to improve that workflow first. And the first step is to develop locally on your machine or to a very close machine only you have access to. For that, there are some different tools. On Windows, you can use XAMPP. On Mac OS MUMP, you can use the really nice Acquia Dev Desktop, which is a packaged version of those tools for specialized or for Drupal. It's really nice, actually. Or you can use a real operating system like Linux and install your environment there for yourself, or yeah, Mac OS X, that's actually quite the same, and it's a Unix as well, so real operating system. And then you got a different workflow. You have your local machine, and you upload your files to the server, and that's solved one problem, namely you test your stuff first on your local machine before you upload it to your production server. It still doesn't solve those conflicts when you have multiple users. Still, you can forget stuff. And the next tool you want to use is version control. Drupal decided, and I think the very right way, to use Git for that. Git is who hasn't heard of Git? Okay, really? You saw it somewhere on a module download page under version control. With Git, you do that thing that's called version control on your everything that's you could call code. I'll just show you in some short steps how you can use that. You have your code on your local machine, and you put that one, or your code, in a repository. That's only a little directory, .git, in your project directory. And since you're familiar with that, I can be quite quick with that. With git add files, you can add it to your repository. With git commit, you can save the state, the current state they're in, and create something that can be transported later on. As an example, you can add your doc root, you commit it, it's in your repository, and you're done. And from now on, almost everything in that document root can get tracked by the version control system. So if you add a new file, it will tell you about it. If you change a file, it will tell you about it. If you update a module, you will see that. So it's almost impossible, if you use that tool, that you will forget something. The typical workflow looks like this. You change some stuff, you do a commit, you add a descriptive message, what you have done, and save that state. You do some other work, you add a new module, you add that to the repository using git add, and then the command or the directory, and give another commit message or do another commit with a good message. So your thing is in a Git repository now, your code. Woohoo. The next thing you want to do, or you can do, is transfer your repository, your changes, to another repository. In this case, this repository will be on the web server on your machine that will serve those files. I called that one integration. It will be more clear why I did that. To do that, Git knows something called remote repositories. And they are just repositories as you use on your normal machine, but you can integrate them with yours. And the command to add that to your local repository, to tell your repository that it should connect to that one, is the git remote add command. You give integration is the name of that repository, of that remote, to be clear. And then you, I chose quite a usual the way to access it. This one is done over SSH. It uses a user git on the server integration.server, and the repository there is called test.git. This one's a bit different to your local one. It's called a bare repository. It's just the repository information without an actual instance of your files. And what you can do with that is the following. You can push your changes, your commits to that server, and you can pull from there. So a push transfers your commits, your changes onto that remote repository, and a pull can import, so to say, changes that maybe someone else did on that repository. So this way you can transfer files quite easily. It's fast as hell because it uses differential way, so just the changes get transferred. If you added some code, it really just transports the diffs, or the patches you may call them. So it's quite fast and secure and encrypted and everything you want with that. But it's still a bare repository. Apache or another web server can't use that repository directly. For this, you have to get the files out of there. That's what you could call deployment on the server, and the server can do that for you. It's not too complicated, since there are several ways. I will just show you one. Git knows something maybe quite familiar, and they are called hooks. So there's a directory in this repository. It's called hooks, and it has some scripts defined with defined file names that get called, you name it, when a certain state in the deployment or in the working on the repository is done. There's something like a pre-commit hook that gets executed before the commit is saved to your repository. You can do certain stuff there. There's an update hook, which gets called when a repository is updated on a remote server. And it works actually quite the same as Drupal module hooks. And there's one you can use to deploy that stuff. So it's called post-receive. When you do a push, the server receives that stuff, and after your commits are received, it calls this script. This is typically a shell script, bash, but you can replace it with Ruby if you like to, or PHP, if you're willing to do that. And this script can go to a document root on the server /var/www/your-site/docroot and do a git pull there as well. So you got your files on that server. Okay so far? If you have any questions, just ask. I have a microphone that I can give to you. No? So there's one little problem regarding Drupal. It has one directory, or maybe multiple if you use multi-sites, that you shouldn't put under control of Git. And that's the files directories under sites/star/files. And you shouldn't put that in Git because Drupal writes to that. Your web server writes to that directory. There's if you use image cache, you upload a picture, image cache transforms it, saves it to styles or whatever you configure, and changes it a lot of time, maybe. You change a style, the file gets regenerated, you add a new one, and so there are a lot of dynamics, and Drupal is, so to say, the master of that directory, and keeps track of that. That's why you shouldn't put it in Git, and to do that, there's one little file in the repository. It's called .gitignore, and you can just add directories, file names with wildcards, and other stuff in there to tell which files or directories shouldn't get tracked by the git command, and be excluded of your repository. So you just do an echo /star/files into gitignore. This adds this new line. You can open it in the editor as well. And if you haven't added the files directory before, you're fine. If you did, you can use the git rm command to pull out that stuff again, and you're done as well. So this is Git and Git remotes to push your code to another server and let the server deploy your code to a document root. This helps as a first step. The second step would be to use Drush. Since you all know Git, you all know Drush, you know your tools. I'll be quick with that as well. You have several commands to download modules, to update, to do database operations, to change variables, and we all love cache clear. So Drush knows something that's called remotes. No, that's not called remotes, but they work quite the same, and they are called site aliases. So the reason, or what you can do with site aliases is run Drush commands on a remote server, or remote site, or different sites, just from your local Drupal installation. To do that, you can create an alias.drushrc.php file in your Drupal installation on the root folder, and or in different other places. You can look for that at the documentation. It's quite clear about that. And this is the most basic thing you could write into that file. So this is a PHP array. You have this array aliases, and with each key you define a different remote or site alias. I have to use that word. It's the one you use with that anyways. Each of these key defines another array, and there you do something. If you used Drush before, these will be quite familiar. You define the URI. That's the host name under which your remote or your site alias site will be reachable. This is integration.server. Drupal.org would be another quite familiar one. And you define in root the directory on that server. So Drush, maybe one thing, Drush has to be installed on the remote server as well. So Drush knows in this case on which directory to look for your Drupal installation. Since you have to get onto that server, you have to define a remote host for SSH. This one's called integration.server as well. And remote user, the user you use to connect with that. For that, you should use passwordless authentication with or key-based authentication, so you don't have to enter the password all the time, but that's it's up for you as a little training. It's not too hard. So what you can do after you define that file, you can call drush at integration status or any other drush command. This will do the following. It connects to the server via SSH, goes to that directory, calls drush status in that directory, and gives you back the output of that command. It's quite handy, actually, so you can always stay on your local installation, and with this little tool, connect to the server and do all the fancy stuff. And if you've been to the Drush session before, or you've used it before, you can do almost everything. And the important stuff right now in this whole deployment or staging setup is syncing the files directory. This is special to the site aliases, if you have site aliases defined. And The reason is you did some stuff on your staging server, you created some files, and you don't want to recreate everything or download everything, upload everything in your local installation or the other way around. So you just want to grab a complete copy of the files directory of the server and load it to your local or the other way around. This is actually, again, the old school way of things where you just transfer files and have no version control over it. So we're still not there yet, but that's a good way to get there. So the command is drush rsync, and then you can use default colon, I don't know the name of English name of the sign again. So files to the remote add integration files. This transfers all your files to the remote server or the whole files directory. And since it's using rsync, if you're doing it a first time, it copies all those stuff. A second, third time, it just copies the delta. So only the changes that have been made or only the files that have changed. Or if you deleted files, if with the right configuration, it can also delete files on the server again. With this, you can synchronize your files directory. But so we have the code in sync, we have the files in sync. Now there's only one thing missing, and that's the database. Best thing would be if you don't have to synchronize the database at all. You can do that by putting everything into code, or as most as you can, using features and all the other stuff. But you can use Drush to do database synchronization, and you just have to enhance your aliases file by adding, that should be well-known syntax. This is the same configuration for your database as you use in settings PHP. So you have your databases array, where you define the default database in this case. You tell it its driver, the database name, username, password, on which host it can find it, and all the other stuff. And now Drush on your local machine knows how to reach the database on the remote server. You can add some other options. You can define some paths and even more than I did here. This is actually not needed to do, but it can help you to set some more useful defaults for your installation. You can, since we are doing database synchronization, you can set no cache, so your dump on the server that will get transferred to you, or the other way around, won't get cached. Sanitize removes or scrambles email addresses and passwords. Maybe you shouldn't actually need to transport those to your testing machine or development machine. And you can define an array structure tables, or even more, where you can tell this drush command which tables not to synchronize. Yes? That's okay. That's a good question, actually. This is for both ways. So he asked this options, is it in regard to the remote database or the alias, site alias database, or your local one? And actually, as far as I know, but I'm not 100% sure, so tell me if I'm wrong, it's for both ways. You typically put there your caching tables, your session tables, watchdog, the ones you're not relevant and actually can get quite huge to transfer and have to regenerate it anyways, so you exclude them there and then save some time. So what you can do then is this command, drush SQL sync default, your local installation, to add integration, and this will create a dump on your local machine, copy that dump via async to the remote machine, log in there, import the database, and that's it, actually. So it's stuff you have done before via the command line, maybe, and use the MySQL command, or verse PHP myadmin, or better, some GUI client that helps. So now we can transfer files, we can transfer or synchronize even better the database. We have solved almost every problem we had with the FTP stuff. The next problem is multiple developers. And actually, since we're using Git for the code and talk to each other when we transfer files in databases, this isn't a problem at all. You can use multiple developers on this that use this integration repository as a remote. Git does everything for you regarding the code. Git is a so-called distributed version control system that is built from the ground up to support teamwork, to allow multiple developers to work on one repository or on one code base. So you have to learn how to do that, of course. You have to learn what is a merge fail. You have to do some called debugging. It's not the right word, but there are some tools that help you to resolve conflicts, like the overwriting stuff I told you before, or it helps you merging those files on an automatic way. So if you changed something in your function A and another developer in another function, it can resolve that automatically. And if you don't have a logic interconnection between those two, everything should work quite okay. So to sum up for now, you can't forget any files anymore. You have faster uploads, since Git does differential uploads. You have version history, which is so needed if you develop. You can work together, and you can deploy your document root on the server. What you should do is, as I told you before, put as much into code as possible so this can work for you. If you have to recreate all your content types or entity types all by yourself all the time via the website or the web interface, this won't help you at all. So there's some tools that help you. I won't tell you about this anymore. Others did that before, and I want to show you something different. So use features for almost everything. Use strong arms for your variables. Use install profiles to set up stuff, and use hook update in for creating test stuff or content you always need. Any questions for now? So now I want to get to the main part of my talk, which won't be as much slides now anymore, just one. And I want to show you a possible workflow where you have multiple developers working on a project. The one down there is the boss developer. It's one just with some special permissions later on. They are all working on their local machines, develop their stuff, and they all use this integration repository where the stuff gets deployed to. So this actually is quite a typical setup when you have multiple people who are working on one code base. This helps a lot, but it can, be improved. And the improvement is done, mostly by Git as well. So you introduce a so-called staging server. This is, for now, just the same setup, but you transfer from the integration repository to the staging setup. On integration, all the development takes place. This is supposed to break. there are bugs in there, you resolve conflicts between your commits, between your functions, everything that the developers do. And if you want to do a proper testing, you transfer this again with Git and maybe those Drush, SQL sync and file sync tools to the staging server. When you're done, or when you reach a certain point in your development life, you will add another stage or another environment, and let's call it live. That's your live site, the one you put out on the internet to access or somewhere else maybe. And this is where your running live code is going to be placed. But you don't want a copy of the integration repository or the head version running there, but a stable, tested, proved to be a reliable one. So a workflow would be the boss guy, or the boss dev, pulls in the staging state of your code and pushes it to the live server. So there's one person or one group maybe even who control what gets pushed to the live site, and Git helps you with that. You can actually secure that via different users, SSH users. Only the boss guy, boss dev, has really access to that code base, and only he can push into the live server or to the live server. So you now have a workflow where you can do integration testing and development, some more testing on the staging environment, and if there is a proper state, you can push to your live server or the one guy and have your live site running. Now, no site will be deployed once and it's done. You have to change stuff, do updates, add new features, do bug fixes, security fixes, module updates, and so on. So you have to implement or to integrate that process into your workflow. And to do proper testing, the first thing you do is transfer your live site into the stage environment and then integrate your changes you did on the integration server. With this, you have the most actual content, user base, whatever, and changes from your live site, and then can test it on the staging environment, and then in the next step, the boss pulls in that changes and can push it out to live again. So this is one way to do it. You can do this much simpler, just using two environments. So the staging environment can be your live site if you're a bit brave, or you can do it much more complicated where you have hierarchies of developers and responsibilities if you have really big teams. But this actually proves quite well and works good. I have some links in my slides. I will upload a PDF later on so you can have a look how Git works. There's a nice introduction. If you want to host your own repositories, there's a nice tool called Gitolite that can create and manage user access to repositories through a Git repository itself. And Drush, okay, I guess I don't need to explain that for now. So please ask.
As I understood, each developer has a local workstation with local database. With local database, Drupal database. You could show your slide. It will be more visual.
Okay. Thanks. Each developer should have his own site, yes, and in own environment, and where you can break stuff, test stuff, Like, yeah.
And each developer has a database, and we have multiple developer databases. And the question is how to avoid the conflicts when two developers made some changes in database, and if we will use Drush with database syncing, it will probably provoke some conflicts on the level of integration platform.
Yes, it will.
How to avoid this?
That's what this is one flaw in that whole concept. And the tools you might use are features, using feature update and feature revert to put your changes in the database. Like if you defined a new view or changed a view, you can use features to put that changes into code. You put that code in your repository, you push that code to the server, and this there, it gets re-imported into the database again. The same with StrongArm, to use variables, and so yeah, they can use Drush async to do that, maybe just to reset. But just pushing your database into the integration machine will probably break some stuff, yes. But the aim is to not use this SQL sync at all, or as little as possible.
Yeah, another question about maintaining production websites. You said in maintaining production websites, you have to transfer data and SQL database in the integration platform and testing some upgrades or new stuff to deploy, and then push them to the production platform. But what happens if there are changes in the production environment during this testing time, especially as new content, new comments? How do you handle this?
For this, you might, or you should, establish additional processes where you can use maybe something like deploy module to transfer. Not deploy module, I'm sorry. Just, you don't change the database regarding to that aspect, but only the code underneath. And that's one way. The other way, you could do a content freeze, site is down, do some testing, push it up, and maybe after a few minutes, everything is fine again. If not, you can use some. There's another quite handy module, actually. It's called Stage File Proxy. You install it on your staging or integration machine, and what it does, if you access asset files in the files directory, it will look, is it there? And if it can't find it, it redirects to the live site so it can pull in those changes or just deliver it via this redirect, so you have maybe that problem solved, and for other stuff you have to establish processes. So, and if there aren't any other questions, then thank you very much. Have a nice travel home, and thanks.